Hey, I hope you're doing well. This is going to be a first video in a supply and demand worksheet that we're going to do in class. So let me show you the worksheet here. There's a supply and demand worksheet where I want to go over with you. This is a long worksheet, so I want to make sure that you have some source to go back to here. So the first thing I want to do is I want to type in this table into Desmos. But before we do this, this is about selling silver dollars. And the first column is a selling price. And then there's a demand for a given selling price. And there's also a supply that's also that suppliers are willing to sell that number in there. So this will all make sense when we go through the whole entire worksheet. So, like I said, the first thing I want to do is enter this data into Desmos. So I do that. And I have three columns. I am going to call them X1, Y1, and Z1. X1 is the selling price, Y1 is the demand, and Z1 is the supply. We're going to treat Y1 and Z1 completely independently of each other. It's just easier to write them into one table here. The question that I want to find the model. I want to sketch the demand function. I'm going to sketch the demand function in Desmos instead of using the little chart or graph paper on the right hand side there. And then I want to set the current price to be $2.50. I want to see what happens. I want to compute the consumer expenditure. That's computing the area of a rectangle. We'll be able to figure out the width of this rectangle and the height of this rectangle. So let me get into Desmos and do some of this. Now there's going to be some fancy code that I'm going to put in here. You do not have to do this. This is for me to demonstrate these are the regions, the areas that we're really looking for. So in Desmos, I have my table and the demand model. Well, first thing I want to do is actually look at the points and make sure that you hold down the shift key and you scale things the right way so things fit. So I'll just leave it like this right now. When I'm looking at these 4 data points, there could be several models that make sense here. I am going to use an exponential model. That's what I'm choosing right now. So the exponential model, remember, looks like AB to a power. So my demand model, y1 tilde, a times b to the x1. Remember the x1 in your problem here. And also remember to click log mode. The parameters I get, a is about 222 and b is about 0.49. So there's the model that I'm going to use. So I'm going to plot this. And that looks pretty good. So the idea here now is to look at a very specific point. When x is 2.5, which is about here where my cursor is, I'm going to go up and it's going to be about like right here is going to be my point of interest. But what I'm going to do to make it a little bit nicer is I'm going to type in x is equal to 2.5. Now, this little added bit is really telling Desmos, don't plot the entire line from negative infinity to infinity, but only go from 0 to, well, d of 2.5, and that's the actual graph itself. So if I enable this, I'm going to get that line. Now, this point right here, x is equal to 2.5, and d of 2.5, it's about 37.31. Now, this horizontal line, well, I haven't put it in yet. I know this horizontal line has a height of d of 2.5, sorry about that, but x is only going to travel from the y-axis to 2.5. So this may look a little bit more complicated than I've done in the past, but it's just to get these two little line segments. I want to compute the area of this particular box. Well, that's the length times the width. The length of this thing is 2.5, and the height is 37.312, or about 37.31, or a little bit less than 38 silver dollars. So that's where this little area calculation comes in. So I'm going to take the 2.5, that's my width, the height is d of 2.5, and I get about $93.30. Now this area, this is a fancy way to get my area, and there's the area of that rectangle. So that takes care of the first three questions in the worksheet. Now the fourth question. Okay, so the fourth question is a little bit more involved. We got to do a little bit more work on here. In fact, you have a homework question very similar to this. So what I want to do is, he's able to spend $3.25 for each silver dollar, but the price is right now $2.50. So that's a good thing. So he actually has extra buying power. This is called the consumer surplus on this. So with this particular model, if I look at this model in here, there's a practical price that if the quantity dips below 1 unit, and I'm thinking silver dollars here, these are single units, I never want to get below that. So part A of this is, at what price does the quantity of the silver dollars drop below 1 unit? And the second part, B, I want to shade the region of the graph that represents the consumer surplus. So that's what I'm going to do right now. Going back to Desmos really quickly. Well, let me hide a few things. I don't need that area. I don't need that line. I don't need that line. I actually don't even need the points at this point. So, the question. At what price does the quantity of silver dollars drop below 1 unit? Well, quantity is my vertical axis. So what I want to do is I want to just plot y equals 1. So if I plot y equals 1, I get this line down here. Let me move this and try to focus in on that line a little bit. Well, I'm going to have to move this over here, and there's an intersection point. Well, if I highlight this cell or go in that cell, I wind up getting a coordinate of 7.574, comma 1. So in other words, my price, my input, my first coordinate, I'm never going to go above, say, $7.60, 7.574, or 7.58, $7.58. So that's the price that I'm never going to go over in this problem. I'm just not going to do it. So the question that we have here is to shade these regions. Well, what I can do is I can shade the region in question. I'm going to get rid of this little line here. Try to get the picture to look like in here. So what is this region right here that I have shaded? Well, I kind of got rid of my demand, my consumer demand in there. And so the surplus is the area to the right of this other region. So what I'm really focusing on is that green region here. This region, the area function, it's not a rectangle, it's not a triangle, it's a little bit more difficult. So what we do here is we take an integral, and my integral starts at 2.5 and it goes to 7.58. That was the value that we found when we looked at that intersection. So I'm just hiding that right now. So this expression right here gets me the area of this green region. Now I want to warn you, in the book, they normally don't calculate this value of X or the price. So when the unit falls or the demand falls below 1, they normally don't do that. Oh, I have a little mistake there. So instead of using the 7.58, what they do is they use a big number up here. And so instead of stopping right here, they actually they include this little wedge right here. But you can see that the numbers aren't that far off. It's your interpretation of this. But the book doesn't go through the extra step of getting the 7.58. They tend to look at the complete area to the right. And that's the first video here. I hope this was useful. And if you got questions, kind of let me know. Wait for the second part of this video as well. Bye.